Hey guys, this is 3.8 for principles, and this is the beginning of this. Man, this is such good problem set. I love what we're doing here. So bear with me, try to stick with me, and understand the ideas that we're going after. In the long run, for us to be able to work equations and solve problems, we have to be able to focus on our priorities and to know what we're really trying to figure out. And this applies to a lot of stuff outside of just mathematics. You know, when we talk about how do we solve problems in the real world, we do always need to have a discussion about what is our priority, what is the actual problem we're trying to solve, and let's make sure that our focus stays on that. Oftentimes when we get into a collaborative experience where we're talking to other people and we're solving problems, you'll find that the group as a whole, the more people that are involved, the more distracted the group becomes. It's very difficult to stay focused on the key principles that you're after. Oftentimes a group will start onto something really important, and they'll find there are other important things along the way that they decide they need to answer as well. And that keeps them from ever answering the initial problem. So, you know, when we talk about mathematics, oftentimes it's about the math, and sometimes it's just about application to the real world. Okay, so in this very first section, it may look like a lot is going on, but it's actually built to make this easier for us to work with. So we're going to look at number 5 here over on the side. We have C equals x plus a all over b. Notice they gave us a bunch of letters. They're not even any numbers, but they also give us an equation that does use numbers. 2 equals x plus 5 all over 7. I actually think it's easier to solve the problem with the numbers than it is the one with the variables, because it just feels like a lot's going on. But the truth is, it's actually the exact same process. And so we're going to write this process as we go for both of them. And I think that if we use the one on the right to help model and give us direction, I think it will help us figure everything out. So our goal in both these problems is to get the x alone. Okay? And whenever we're solving or rewriting equations, which is essentially the same as solving, we want to go through SADMAP. So addition, subtraction, then multiplication and division, then exponents and parentheses last of all. Now something you have to understand, when we have addition inside of a division, it's as if there are parentheses around that addition. Okay? So you have to imagine the parentheses there. So if we imagine these parentheses here and here, it means that that's the last thing I'm going to touch. I'm not going to get into that stuff till everything else has been removed. So step number 1, we see that there's a division by 7, and if I want that division by 7 to go away, I'm going to times by 7 on both sides. That's going to give me 14 equals x plus 5. And notice I don't need the divided by 7 anymore. So I also don't need the parentheses. I'm going to do the same thing I just did with the numbers over here in the variable version. I multiplied by whatever was in the denominator. So again, I'm going to multiply by whatever's in the denominator, which is b. So times by b on both sides. Over here the b's cancel just like the 7's canceled. And I get bc, whatever that is, it's b times c, equals x plus a. Again, my goal is to get the x alone. And so the next step would be, say, how do I get x plus 5 to just be x? Well, if I subtract 5 from 5, it becomes a 0. So if I do that to both sides, I will get 9 equals x. And my x is alone. Over here, I want to do the same thing, but it's not a 9, or a 5, it's an a. I'm just going to minus whatever the heck a is, and my answer will be x equals. Now, this is where it gets a little bit, be careful here. I don't know what a is. I also don't know what b times c is. It would be ridiculous for me to try and subtract something when I don't even know what it is. So I'm just going to write down that it has to happen. I need bc to subtract a. I have no idea what that is. But I do know that if I ever figured out what a, b, and c were, I could figure out what x is. And if x was, if a, b, and c were 5, 7, and 2, right? So let's assume that a is 5. So we're done. But I want to show you what this actually does. B is 7 and c is 2. If I use those, b is 7. That'd be 7 times c is 2 minus a, which is my 5. Well, 7 times 2 is 14, and 14 minus 5 is 9. This is not something you need to be doing. This stuff down here, not important for your assignment. I want you to understand that what we built up here is an equation that is valid for lots of specific cases. It's a generic formula. Here we talk about it being a literal equation, okay, and then there's the specific case. And that's what the x equals 9 is. But we're able to rewrite equations for that purpose. The next section of your homework, 11 through 19, is all about solving so that you have a y equals. We are eventually going to be graphing lines. And when we graph lines, sometimes we use a calculator to help with that. And whether we're doing it by hand or using a calculator, it is so much easier if we're able to have a y equals equation. So our goal on this next set of problems is to solve it so that you have a y equals. It doesn't matter if y is on the right or y is on the left, as long as it is completely alone and isolated. Let's take a look here at number 13. Okay, we have 12 equals 9x plus 3y. Again, we're going to start with our SADMEP approach. Whoop, going down the line kind of wonky there. We want to move any addition and subtraction that we can before we worry about multiplication and division. As I come over here, I notice that the 9x is being added to the 3y. And remember, the y is what we're after. So I need to get rid of this 9x. Because it's a positive 9x, I will subtract 9x. Subtract 9x. Here, my 9x's are going to cancel. I still have a 3y on the right. On the left, okay, what is 12 minus 9x? Because the 12 does not have an x and the 9 does, they can't be combined. So I'm going to take my 12 and minus 9x. I'm not going to actually try to simplify that. That's like over here when we had bc minus a. I don't know what that is. I don't know what 12 minus 9x is, so I'm going to leave it. Last step for getting y alone is to get rid of this 3. To get rid of the 3, we're going to need to divide by 3 because it's times 3. And if I divide by 3, those will go to a 1 and cancel out. Now, when I divide, I have to divide everybody by that same number. So I'm going to divide the 12 by 3 and the 9 by 3. This will give me y is equal to 12 divided by 3 is 4 minus 9 divided by 3 is 3x. All right, so our goal is to get the y alone. If you have questions that you want to talk about in class, I'd be happy to go over those, but hopefully this will help fill in any gaps in case you miss class or you have questions when you get home. Good luck, and we'll see you in class.